I decided not to give you a quiz over this chapter. Okay, so we're just going to basically, big grade wise, we're going to have another test at the end of next week, and then we'll have your notebook check. Okay, and then the semester test. Okay, so I will not be giving a quiz. Our test over this chapter will be next Friday. That's what my plan is. All right. So if you're not going to be here after I go over today's lesson, you'll need to get your workbook pages because we're doing 6, 1, 2, 3, and 4, the practice side. Okay, tomorrow. All right. So today we're going to talk about rectangles. Are you excited? Last 2 days we talked about parallelograms, so we are going to get a little more excited and talk about some rectangles today. Okay? And a rectangle is a quadrilateral with 4 right angles. Okay? And because it has 4 right angles, what's true about the opposite angles? They're congruent on both of them, right? And so if your opposite angles are congruent, what does that also make? A parallelogram, right? Okay, so a rectangle is a parallelogram as well, and so it holds all those properties of the parallelogram, plus it has 4 right angles, okay? And if you'll remember, the properties were opposite sides are parallel, opposite sides are also what? Congruent. Your opposite angles are congruent. Obviously, we just talked about that. What about your consecutive angles? They're supplementary. They're both, the consecutive ones are going to be right angles. What's true about the diagonals? One of them makes 2 congruent triangles, right? And in this case, it would be 2 congruent right triangles, right? If you drew a diagonal here, then those 2 triangles will be congruent right triangles, right? Okay. And then what happens if you draw both? Huh? They bisect each other at their midpoint, right? Okay? They bisect each other at their midpoint. Alright. Plus, it's got the 4 right angles, right? Then it has another property, okay? It has another property, and it is that the diagonals are congruent to each other. The diagonals are congruent to each other. So AC is congruent to BD. So it holds all the properties of the parallelogram. It has 4 right angles, and the diagonals are congruent to each other. Now, because the diagonals are congruent to each other and they bisect each other, what's true about all 4 of these parts? All 4 of these parts are congruent. That's not necessary. That's not true in a parallelogram, but in a rectangle it is. Okay. In a rectangle, these 2 parts are congruent and those 2 parts are congruent. But in a parallelogram, these 2 parts are congruent and those 2 parts are congruent. In a rectangle, all 4 parts are. Alright, so let's do a couple of examples here. It says quadrilateral MNOP is a rectangle. If MO is 6x plus 14 and PN is 9x plus 5, I want to find x and I want to find PT. I want to find x and I want to find PT. I'm going to find x first. What are we going to do to find x? Set the diagonals equal to each other. So I'm going to say 6x plus 14 equal to 9x plus 5. And I'm going to solve. Okay, subtract 6x from both sides. Subtract 5 from both sides. Divide both sides by 3. And so my x is going to be 3. But then I want to go and find PT. What am I going to do to find PT? What do I have to find first? Huh? The whole segment, PN, right? Okay, so I'm going to find PN first, so I can plug 3 in there. 9 times 3 plus 5, which is 27 plus 5, which means PN is 32. So if PN is 32, what's PT going to be? It's going to be half that, which is 16. Okay. Here's another one. It says quadrilateral ABCD is a rectangle. Find x and y. Okay. What are we going to do to find x? We have 2 angles here that have x in them. Do they have a relationship? It's a rectangle. Yeah, so they're complementary. They make 90 degrees. So I can add them together. 9x plus 20 plus 4x plus 5, and that's going to be equal to 90. And so I end up with 30 What's my relationship between those y's? They're alternate interior. Remember, your rectangle has parallel, opposite sides are parallel. And when that happens, your alternate interior angles are congruent to each other. So I have to set y squared minus 1 equal to 4y plus 4. What do you do when you have a y squared and a y? Remember? Well, but you can't subtract a y from the y squared. Okay? You have to what? You have to get everything on the same side so it's equal to 0, and then do what? Then what am I going to have to do? Factor, right? I have to factor it to binomials, okay? Alright, so remember the product and sum we did at the beginning of the year? Okay? It is in Algebra 1. Your product is the product of the first and last coefficient. The sum is the coefficient of your middle term. And you want to find two numbers whose product is -5 and whose sum is -4. Okay? What multiplies together gives you -5 and adds together to give you -4. -5 and 1. Now, because this has a leading coefficient of 1, I can just go straight to my factors. Okay? And it's going to be y minus 5 times y plus 1 equals 0. If this was something other than 1, then you have to break it into 4 terms and factor it that way. By group. Alright, so once I get it factored, then I have to send those factors equal to 0, y minus 5 equals 0, and y plus 1 equals 0, and solve for y. So y ends up being 5, and it ends up being -1. Sometimes with this quadratic equation, when you have a quadratic, you have an extraneous solution. That means a solution that doesn't work. So I have to go back and test it. So if I put 5 in here, I'm good, right? But what happens if I put -1 in there? What does it give me? It gives me 0, doesn't it? And can you have that angle measure of 0 there with the diagonal? No. Okay? So this guy doesn't work. So this is my answer, +5. Alright. Go to the next thing. Quadrilateral JKLM is a rectangle. If the measure of KJL is 2x plus 4, and JLK is 7x plus 45, I want to find x. What do we have going on here? No, because those aren't formed by parallel lines. These two angles here. What is this? It's a rectangle, right? And if I draw the diagonal, let's create a right triangle. So what relationship do these two angles have? They're equal to 90 degrees, because remember the acute angles of the right triangle are complementary. You could even add all three of them together and set it equal to 180 if you didn't remember that, right? So we know that all the angles are 180. So we can eliminate a step here and just add them together and set them equal to 90. So we have 2x plus 4 plus 7x plus 45 equals 90. So that gives me 9x plus 49 equals 90. Subtract 49 from both sides. And divide both sides by 9. And that ends up being 4 and 5 ninths. What is that as a decimal? Does anybody know that without using a calculator? Do you know that any time you have a fraction that has a denominator of 9, it always repeats as the numerator? Do you know that? So this is actually 4.5 repeating. So like if I had 1 ninth, that'd be 0.1 repeating. If I had 2 ninths, it'd be 0.2 repeating. 3 ninths is 0.3 repeating, which is also a third, right? And so forth. This is a little tricky for you. Okay, so the next problems that we're going to work kind of works backwards like we did yesterday where we have to prove that it's a rectangle, okay? And I'm going to show you two different ways that you can do that. One way is by using the definition, okay? The definition says you have four right angles. Well, if you have four right angles, you can look at the slopes of those sides and determine whether they're perpendicular, okay? So for example, if this right here was 1/3, then this would need to be -3, right? In order for there to be a right angle, and likewise all the way around. So you might So if it's going to be a rectangle, the opposite sides are going to be the same as far as the slope, but then the consecutive side are going to be opposite reciprocals of each other. Okay? Also, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Now, the only problem about using this, okay, because we know that the diagonals are congruent. So if we could show that the diagonals have the same length using the distance formula, we could say that it's a rectangle only if we know it's a parallelogram to begin with. If all they tell you is that it's a quadrilateral, I would not use that test because the diagonals of an isosceles trapezoid are also congruent. We haven't learned that yet, but it's not a parallelogram. Okay, so it has to be a parallelogram first, and then if the diagonals are congruent, then you can test that, and that'll tell you that it's a rectangle. Okay, I would use slopes if at all possible. When I did this, because that's easier and quicker. Okay, you can look at the opposite ones and tell it's a parallelogram, and you can look at the consecutive ones and tell if it is a rectangle. All right, so let's look at this example here. Quadrilateral FGHJ has the following vertices. Okay, so we've got FGHJ. And we want to determine if it's a rectangle. Now, it just tells us that it's the quadrilateral. If it had said that it was a parallelogram, then I would just have to look at the slopes of two consecutive sides. But because it just says it's quadrilateral, I have to look at the slopes of all four sides, and I have to determine that the opposite ones are the same, and the consecutive ones are opposite reciprocals. And if that's the case, then it's going to be a rectangle. Okay, so let's start out by looking at the slope of FG and HJ. Alright, so look at FG first. Find the slope. That's -1 minus a -5 over -4 minus a -2. And that's going to give you 4 over -2, which is -2. Then I'm going to look at HJ, -2 minus 2 over 4 minus 2. That's going to be -4 over 2, which is -2. Okay, so that tells me that these are parallel, right? Now I'm going to look at FJ and GH. Okay? Alright, so I'm going to look at the slope of FJ, and that's -1 minus 2 over -4 minus 2. That gives me -3 over -6. What's that equal to? That's equal to 1/2, right? So that was FJ. That makes it 1/2. Well, that tells me that these are perpendicular to some of those, right? Then I want to look at the slope of TH. And that would be -5 minus a -2. And -2 minus 4. Which is -3 over -6. Which is a positive 1/2. Okay, so that tells me that these are parallel and that these are also perpendicular, right? So is this a rectangle? Yes. Okay, we say FGHJ is be sure that it meets the ideal playing field requirements. They measure the sides of the field and its diagonals. And AB is 60, and BC is 30, and CD is 60, and AD is 30, and AC is 67, that's the diagonal, and BD, the other diagonal, is 67. Explain how the recreation center can be sure that the playing field is rectangular. How do we know that that's rectangular? Yes.
The opposite sides are congruent and the diagonals.
Okay, very good. I need to look at both of those things, right? The opposite sides are congruent. That tells me it's a parallelogram. And then the diagonals are congruent. That tells me it's a rectangle. Very good. Okay, so that's what we would say is yes. Opposite sides are parallel, making it a parallelogram. And the diagonals are congruent. Yes. Yes. Making it a rectangle. So opposite sides are parallel, making it a parallelogram. Opposite sides are not parallel. Opposite sides are congruent, right? Opposite sides are congruent, making it a parallelogram. And the diagonals are congruent, making it a rectangle. Opposite sides would be parallel, but we just know that. Alright, so we talked about rectangles today, right? And we said it's a parallelogram. It holds all the properties of a parallelogram, right? Plus two more things. What? All right angles and diagonals that are congruent to each other. So a rectangle is a parallelogram, right? But is a parallelogram a rectangle? Not always, right? Sometimes. Okay? Alright. Your assignment is on page 462.